So those of you that follow me on Twitter have probably already seen me post about these two chips here. And this is a project in this box that's going to go with these chips. But let's go ahead and talk about these first. So this is a MOS MCS6501. It's a very rare MOS processor. So this was really the first processor that MOS released. It's Motorola 6800 pin compatible, even though internally it's a 6502. MOS was sued by Motorola over this chip, and MOS changed the design to produce a 6502. The 6501 here has that same dual phase clock requirement as the 6800, and that's a dual phase non-overlapping clock that drives very near to 5 volts, so it's a little bit difficult clock to produce. I also have here an MCS 6530-004. This is a Riot chip, ROM IO timer chip. It's got some RAM in it as well that implements the TIM, the Terminal Interface Manager. So this is the TIM implementation. It basically connects to a serial terminal, and it gives you a simple monitor where you can put values into memory, look at memory, execute code, that kind of stuff. So these two chips are actually can work together, and so to get these two working together and to prove that they both work, I picked up this package from Glitch. Glitch Systems, I think. He's on Tindie. He's on YouTube, or not YouTube, he's on Twitter. I follow him there, and he's put this kit together, and I have ordered probably the first one he sold, and I thought we'd look at the parts here together and talk about this 6501 project going forward, because the biggest thing that I need to do is prove the 6501 is operational. For those that follow me on Twitter, you saw me some time back post a link to somebody selling one of these 6501s on eBay. It was a tested good processor, and I want to say it sold for $4,500, though I'm not sure if it was $4,500 or $5,500. Anyhow, it was a chip that just was like, wow, really? That person's got their second and last one up there for sale. It went up today, and it was already, I want to say, at $2,000 or $2,500 with 6 days left to go. Rare, and people want them. Doesn't mean I'm going to sell it, but it actually has some value, so I'd love to know if it works. So what this is from his Tindie site is, we'll pull it out and look at it here if I can get my fingers to cooperate. It's a pretty neat little kit. So some of you may recognize this, you may not. This is an OSI 400 CPU board. So it is a replica of the Ohio Scientific 400 CPU board that's designed to take a 6800 or a 6502 or 6501. Can actually be made to work. It gives you spots for a couple of 1702 EPROMs. There's a little bit of control logic and a spot for an ASIC here, an ACIA, an asynchronous interface adapter. And there's a monitor, and this can get you a basic standalone system up and running. Well, this board can be modified to use the 6530 over here in this socket area here. So I can actually use this to bring the system up, to then prove the 6501 works, then to prove that the TIM chip, the 6530-004, works. It's a nice reproduction. It is solder masked on the backside, which the original wasn't. This, I believe, has plated through holes looking at it, which is really nice. The original didn't have plated through holes. But what Glitch has done is he's taken from selling the blank board to actually selling a parts kit. And I picked up the vintage parts kit, which has vintage looking you know, capacitors and resistors and stuff to make the board look as much from the era as possible. Nice little Glitch sticker. This looks like logic ICs. This looks like CPU and other stuff. Let me find a pair of scissors here, since this looks to have been sealed. We'll take a look at what's in here and why I picked the options I did. I get enough that it opens. So the option I took includes a 6512 Motorola processor. So the 6512 is essentially compatible with the 6501. So with this chip, I can make sure that the clock works, the dual phase clock, the ROM monitor, those kind of things. I can make sure that the system will run with this processor and the ASIC here, the asynchronous controller, and the ROM. So processor, ROM, and the async chip. And then there's some little bit of glue logic that ties it all together. And then he's included in this bag. I guess I'll cut it from this side. I'm guessing these are going to be 2102s, maybe. Yeah, there's the 2102s. Then there's a row for 2102s down here for some RAM. So the process is going to be to get the board built. He's included sockets, etc. here. They look like they're nice quality sockets. They are machine pin. Get the board built, get it running on the 6514 here, or 6512, using this monitor and the ASIC, and then I should be able to swap in the 6501 into this socket. And if it's a good chip, the system should run in that condition. Because internally this is 6502 compatible. It just happens to use the dual phase clock, etc. So that'll give me a test bed. Then I should be able to remove these two chips from the system and put the TIM chip in over here, the 6530-004 over here, and hopefully get the system to run the monitor code out of the ROM over here in the 6530. It's got the serial stuff built into it. I'll pick up a couple of pins here for the serial port and hopefully get both these chips up and running and proved running on this board, which will be really cool if I can, if the chips are good. Okay, hand. Put that back in there. There's going to be a little bit of TTL logic here. So there's some ALS 20s, LSO4, pretty standard stuff, LSO3s. 7400s, and there's a lot of low power Schottky LS. Some actual 8T26s, which are drivers, I believe. N8T26AN, I believe those are drivers. Trying to read the numbers on these. Not having a lot of luck. See if I can get the light right here. Okay, we'll go a step further and add some light from my old eyeballs. Oh, 7407s. So those are 7407s. It's just hard to see, which I believe are open collector drivers. Get that lamp turned off so it doesn't cause all kinds of glare. So this should be a pretty cool project. I'm looking forward to getting this guy built up and running, and hopefully having two good chips here to play with. So take a look at the bags of components here. Diodes, despiking caps. There's some temperature controlled, so NPO I think it is. Capacitors here that are used to keep the clock frequency pretty solid. That's a tantalum cap. I think it's going to probably be the one over here on the power input. So the power comes in down here on this connector. Address and data are down here, I don't remember, and then there's some open pins here that can be used by the user. And one of the things I can do is there's an open port on the TIM chip, an unused port that I could connect to those down there to do, basically a full byte of I/O if I wanted to. I really don't want to lose those. I've been reading through the documentation on the OSI 400 and the documentation on the 6501 and the 6530. Those look really nice. I think this is the core timing for the system. There's a trimmer pot that gets mounted. I think it uses a 555 in the end and another temperature stable film capacitor. So I believe this all has to do with accurate clock generation. Let's see, there's one more bag floating around, and these are, I'm sure, going to be all the resistors. And they are very much period correct resistors. They're that Allen Bradley style where they're square on the ends. I've got some of these in my stock, but they're very period accurate resistors. So in the end, we should get a very period accurate build here. It should look very much the part. I wanted to build an OSI system for ages. I've just never got around to it. There was an OSI 800 with dual 8-inch floppy drives on eBay that went for a fairly reasonable price some time ago that I nearly bid on and then didn't. And if I'd have bid the amount I thought about, I think I would have won it. But it is what it is. There are the connectors here. If I can get one out, I don't want to bruise, bend pins up these. Okay, I'm going to have to look at how these get mounted, because in my mind, do the pins, maybe the pins have to get bent on them to put them in. That could be because they mount on the board this way. The board sits in this way, and there's a back plane here with the pin headers. I would have expected these, however, to... I'm guessing I'm going to have to bend those pins. I've got some very similar, if not the same, connectors as these for my H8. Yeah, I'm guessing those pins have to be bent down to get this to work. I'll email Jonathan and ask. But anyhow, there it is. There is the OSI, what he calls the vintage kit. It's got the vintage parts. It's the vintage looking parts. So the board is larger than I thought. It's a really nice looking board. It's accurate layout wise to the original board. www.glitchworks.com, so glitchworks.com. I will put the URL in the notes here on the video. And then osiweb.org is where the remains of the OSI company seems to live. So it's pretty cool. The layout of the board here is kind of interesting, and I guess I'll speak to this a bit while we're in this video. There's a 14-pin package down here that is chip V, that if I remember correctly is a 7404, I believe. I believe this is a 7404, and only one inverter is used. And none of the other inverters in the package are used. So there's breakout headers here that you can connect to use those inverters for something you're doing, and the modification for the TIM chip actually makes use of this. And we've got the same thing down here on where the 7400 position is, where one of the AND gates, or NAND gates, is not used down here. And so there's breakout pins. So with the socket in, the chip in, you can actually get to those pins easily and wire from the top. It's the same thing with the TIM chip here. The data bus is actually routed. So if we look underneath, the data bus is routed. Power is there, but the other chips are floating. And again, there's tie points you can tie to, because this can take the Riot chip. There's a whole bunch of other chips that can be dropped in here from MOS. So it's kind of cool that, you know, there's a way to do external access here, and I need to decide how I'm going to approach this. In my mind, what I envision is a 40-pin IC socket in here for the TIM chip, and then soldering in pin headers in these facing upwards. Then I can wire wrap on the top of the board as I want to. That's not necessarily period accurate. People would have been just poking wires into the holes and soldering them, but it gives me more flexibility. The problem with that, well, for this device it isn't a problem. The original board didn't have plated through holes, which would have made that potentially problematic. Let's look at what's down here. No, that concept would have worked, because there's double pads tied together on the back side, so the extension pins would actually have been solderable. Like I say, in this case he's done plate throughs, which is why there's pads, you know, small pads on the top. So that actually is something that may have worked on the original, because where there's unused gates, the positions are added there, or connected on the back, so soldering would work. There are a few connections, you can see a couple here, that on the original board you would have had to solder on the back of the board and on the face of the board on this side as well, because there'd be no plate through on those. And so, you know, this wasn't uncommon back in the day, where you would have to actually drop a chip in and solder the leads, or stand a socket up off the board so you could solder underneath. Some people used wire wrap sockets that they could stand up off the board, say a 1/4 inch, so that they could get up under the pins and solder on the face of the board, because this has got plated through holes. That's not really necessary. If you look at, we'll pull one out. You know what, I meant to be a short video. It's going to be a nice long video. With the machine pin sockets, we can drop one in here, and then we'll look at what I'm talking about if I can get it in the right position. There's some height here, and you can actually see the metal pins. So I don't know if that's coming through in camera or not, but the plastic body isn't flush up against the PC board. There's a little bit of height here. And if you were careful, you could solder those pins to the front copper. So, in this case where the processor goes, you would need to make a solder joint on an original board right here. And you could do it with this style of sockets. Because I've got a plated through board here, it'll be a little bit easier to assemble. But ultimately, I will want to make those kind of connections just because it makes it look a little more authentic. So, pretty excited. This is going to be a cool build. Should be a lot of fun. And then, as we introduce the 6501 and then the 6530 TIM, this will be a really unique system at that point. The TIM chip seems to be nearly as rare as the 6501. The MCS 6530 is the Riot, and then the 004 is the TIM variant. So there's a 00, there's a number, a dash number after, and that number will tell you what that chip, what the ROM in the chip is meant to do. I'm aware of 001 through 013, I think, based on stuff I've seen that did various things. I mean, it's a mass programmable ROM inside. Pretty cool. This 6501 is the 34th week of 75, and this guy here is the 48th week of 75. Those are old chips. Nice, beautiful packages. Pristine. The pins are straight. There's no corrosion. I'm really lucky to have these. I don't know where I actually got them. I have no clue. They've been with me for years, potentially decades. In my chip collection, it was just a fluke that I spotted that 6501 on eBay and watched it, bid up at the end and sell for $4,500 or $5,500, and I went, damn. And a couple weeks later, I was digging for a chip in my collection and went, wait a minute, I have a 6501, holy moly. Anyhow, enough about me. We will pick this up in a series of videos. We will build it together. I'm pretty excited. I will do probably an independent video to talk about the TIM monitor itself. That'll probably come after we verified the TIM works, maybe before. As you know, I don't organize this stuff. I don't plan too well ahead. I just kind of shoot video as I do things, and I try to make some logic in the videos as they're released. At least the numbers are sequential for a series of videos. STB 800, STB 801, STB 802 will be part of a series. And what else to say? Really happy with the quality of the board. It looks great. It looks like it was probably Hazel hot air surface leveled. Original boards would have most likely been blank copper. But take advantage of the modern stuff when you can. It makes it a little easier to build. So 12th week at 75. It looks like when this board was laid out, it's Rev B. MC probably did the layout. Those are probably his initials. 1275. Really nice reproduction. So Jonathan's just done a wonderful job with these. At least I'm assuming he's the one that did the reproduction. This board, you may not have noticed, follows the old school paradigm of I have vertical lines all over this side of the board, and when I flip over, I have horizontal lines. And that was a really common design pattern back in the day, where every place you could, you ran horizontal on one side of the board and vertical on the other. There is some nice hand-taped stuff here that would have been hand-taped with the nice curves. The fact that the time was taken to reproduce those is really pleasing. It's an interesting layout. So anyhow, yap. I never shut up, I know. I will end this one here, and I will see you in a future video. as we put this guy together and see what it does.